So far in math, we've been learning about exponents and order of operation. And before I get into telling you about prime and composite numbers, I wanted to kind of review that information with you. So far, we've learned that exponents are um, the number that tell the base how many times to multiply itself. So this expression right here, 3 to the fourth power, is written in exponential form. That 3 is the base, and the 4 is the exponent. The 4 is telling you how many 3's you need to multiply. Since my base is 3 in this exponential, then I am tripling. I am not counting by 3's. I am tripling by 3 4 times. So for example, 3 to the fourth power written out in a string of 3's to show what my base is 3 times 3 times 3 times 3. That's 3 to the fourth power. And I will not count this as 3, 6, 9, 12. I'm not counting by 3's. I am tripling. So what that means is I start with 3 and I triple. If I triple, that means I'm going to do 3 times 3 and get 9. Then I'm going to triple the 9 and do 9 times 3 and get 27. Then I'm going to triple the 27 and do 27 times 3 and get 81. Therefore, 3 to the fourth power is 81. The next thing we learned about exponents are the laws of exponents. And I do apologize if there's a glare on the screen. It's the camera on my computer. But anyway, the laws of exponents, I gave them little acronyms to explain the laws of exponents. MLB was one acronym, and that just means multiply like bases. So in this exponential expression, 3 to the third power times 3 to the ninth power, first of all, identify your base. 3 will be my base because it's that bigger number. 3 and 9 would be my exponent because they are that smaller number, like written up high in the sky. These exponents is telling me how many times to triple. Since 3 is my base, I am tripling. If 2 was my base, I would double. If 4 was my base, I would quadruple, so on and so forth. So 3 to the third power means that I'm going to triple three times. 3 to the ninth power means I'm going to triple 9 times. This means I'm going to say 3 times 3 times 3, 3 to the third. 3 to the ninth means I'm going to say 3 times 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 3. 9 threes. So a shorter way to do that would be just to multiply the exponent so you can get a total number of times that you are going to triple, which multiplying is nothing but repeated addition anyway. So 3 to the ninth power times 3 to the third power, or 3 cubed, will be 3 to the 9 plus 3, or 3 to the 3 plus 9, which will make 3 to the 12th. And using the laws of exponents, we're going to just leave it like that. We're not going to actually triple 12 times. We're just going to leave it as 3 to the 12th power because what I asked you to do is show me what you would do to the exponent. And this step right here is actually showing me what you would do to the exponent. You would actually add the exponents. The next law was DLB, dividing like bases. Since multiplication and division are inverse operations, then when I divide like bases instead of adding, I'm going to do the inverse of adding. I'm going to subtract. So 3 to the ninth divided by 3 cubed would be 3 to the 9 minus 3, which is 6. Okay, and that's because if I wrote this string of 3 out 9 times, I would have 9 threes in my numerator. I would have 3 threes in my denominator, which means that I can divide 3 into 3 times because my denominator would have 3 threes. So there'll be a 3 on the top divided by a 3 on the bottom, another 3 on the top divided by another 3 on the bottom, and then a third 3 on the top divided by the third 3 on the bottom, which will leave me 6 threes on the top. So my answer will be 3 to the 6th power using the laws of exponents. Now, if I was to say evaluate, you would actually multiply that out and solve. But we say use the laws of exponents, so you can leave it like this because I'm interested in knowing this part right here, what you would do with the exponents. And when you divide like bases, you subtract the exponent. The next law was called ZP, or zero power, and that one was pretty simple. Anything to the 0 power is 1. If I had a million to the 0 power, that would just simply be 1. Okay, so ZP is the 0 power. Anything to the 0 power is equal to 1. This next law is the PTP law, and this is where you might have the glare on your computer, and I apologize. 3 to the third power to the fourth power, What that means is this 3 to the third power is going to be done 4 times because this exponent outside the parentheses tells me how many times to do what's in parentheses. What's in parentheses is 3 to the third power, which is 3 times 3 times 3. I'm tripling 3 times. So this says triple 3 times 4 times. That's what this says. So instead of tripling 3 times 4 times, I could take a shortcut and just use the PTP law, which is power to a power. And that law states that anytime I have a power to a power, I will multiply exponents. So instead of doing 3 to the third power 4 times, I just will multiply 3 times 4, and that'll give me 3 to the 12th power. And that's what power to a power law states. Down here, I'm just showing you an example of evaluating. Say I didn't have like bases and I couldn't use any law of exponent. For example, 2 to the 4th power plus 3 to the 2nd power. The bases aren't alike. This has a base of 2. This says double 4 times. This says triple 2 times. Doubling and tripling are not the same, so the base is not the same. So what I would have to do is simply solve this expression. I would have to actually do 2 to the 4th power, and that means double 4 times, because if my base is 2, I'm doubling. If my base is 3, I'm tripling. If my base is 4, I'm quadrupling. If my base is 5, I'm getting 5 times as large every time. So right here, 2 to the 4th power, I would do 2 times 2 and get 4, 4 times 2 and get 8, 8 times 2 and get 16. So 2 to the 4th power would be 16. And then 3 to the 2nd power would be 3 times 3. And 3 times 3, or 3 squared, is 9. So then I would do 16 plus 9, and I would get 25. Which leads me to the next thing we were studying, orders of operation. And that was kind of an order of operation problem because I did exponents before I added. So that could definitely classify as an order of operation problem. All right, this particular problem we did on one of our homework assignments, and I just want to review order of operations using this problem. The first thing I taught them to do was to use this hopscotch type diagram. Please excuse my dear Aunt Sally, and I'm sure you've heard that before. You probably learned that in elementary school. All right, so please means parentheses. The P stand for parentheses. So when I start my order of operation problem, I always check for parentheses first. I look into my problem and I have 2 sets of parentheses. Well, the rule is just do whatever you have from left to right. So if I have 2 sets of parentheses, I'm going to do them in order from left to right. In the first set of parentheses, I have subtraction and I have exponents. So I just normally do this, subtraction, exponent. And then I pick which one I'm going to do first. Well, if I look in the hopscotch, E comes before S because I'm starting from here and hopping up. Okay, so E comes before S, so I'm going to take care of the exponent. I'm going to underline that exponential, which is what I taught them to do, or what I taught you to do. So 41 minus, and 3 to the 2nd power is going to be 3 times 3, which is 9. So this is going to be 41 minus 9. And I'm still going to put it back in parentheses because I haven't done everything that's in the parentheses yet. Plus 18 divided by 2. So then I'm going to go back to that same set of parentheses because I hadn't taken care of everything that's in there. And I'm going to do the subtraction. 41 minus 9 is 32. So then I'm going to have 32 plus, and I'm just going to write what I haven't taken care of yet. And I'm going to go back to the hopscotch starting with P, and I'm going to say, do I have any more parentheses? And the answer is yes, I do. I have this set of parentheses, and what's inside this parentheses is only one math problem, and that's 18 divided by 2. So I'm going to take care of division. That's in parentheses. So I'm going to cross that out to let myself know I'm getting ready to take care of that. So I'm going to have 32 plus 18 divided by 2 is going to be 9. So this is going to be 9. And now I have, oops, I didn't mean to put that parentheses there. So now I just have my final problem, which is 32 plus 9. And the only thing I have left to do is to add. So I'm going to add 32 plus 9, and I'm going to get 41. Okay. Now say, for example, I had an addition and a subtraction problem in this order of operation problem. Well, I would do them in order from left to right. If addition came first, I would add first. If subtraction came first, I would add first. So when you're looking at this diagram, when you get here, that these two M and D, they side by side, you do them in order from left to right. So whichever one comes first is the one you do first. If the multiplication problem in the sentence is first, you multiply. If the division problem in the sentence is first, then you would divide first. Same thing with addition and subtraction. After you get rid of all the multiplication and division, you take care of the addition and subtraction in order from left to right. Finally, moving on to something new that we're going to discuss are prime and composite numbers. A prime number is a number or multiples with only two factors. So any multiple that have exactly two factors would be a prime number. So it has to have exactly two factors. Can't be less than two, can't be more than two. So it has to have two factors in order to be prime. And those factors have to be one in itself. For example, 1. 1 times 1, well, 1 are the only factors that can make 1. So 1 is not prime because it doesn't have exactly two factors. It has less than 2. 2, the only way you can make 2, the multiple 2, is to multiply 1 times 2. Use these two factors, 1 and 2, to make 2. Well, this would be a prime number, and this is the only even prime number. 2 is the only even prime number. No other even number is prime except 2. 3, this multiple 3, the only way to make 3 is to do 1 times 3. Okay? And 1 times 3 are the only two factors that can make 3, so 3 would be a prime number. The multiple 4. Well, the only way to get a multiple of 4 is to multiply 1 times 4 or 2 times 2. So if I count those factors, then I can count 1 as a factor of 4, 4 as a factor of 4, and 2 as a factor of 4. So I have 3 factors that can make 4. So 4 would not be a prime number because it has more than 2 factors. Remember, a prime number has exactly 2 factors. All right, so now if a number is not prime, then there's only another choice other than 1 and 0 is to say that it is composite. So when a multiple has more than 2 factors, it is a composite number. For example, the multiple 5. Well, the only way to make a multiple of 5 is to multiply the factor 1 and 5. So 1 times 5 does make 5, but that's the only way to get 5. So 5 would not be composite. It would be prime because it has exactly 2 factors. 6. The only way to get a multiple of 6 is to do 1 times 6 or 2 times 3. Well, if you count the number of factors, that's 1, the 6 is another, the 2 is another, the 3 is another. So that would be 4 factors that make 6. 4 different numbers can make 6. 3 can make 6, 2 can make 6, 6 can make 6, and 1 can make 6. That's 4 factors. 4 is more than 2, so 6 would be a composite number. 1 times 7. The only way to get a multiple of 7, to get the multiple 7, is to do 1 times 7. And that would be exactly 2 factors. So 7 would be a prime number. If you do 8, if you think about 8, 1 would make 8, 2 can make 8, 4 can make 8, 8 can make 8. Well, that's 4 numbers. So since I have more than 2 factors that can make that multiple, 8, then that 8 is a composite number. Remember, prime has exactly 2 factors, one in itself. Composite numbers have more than 2 factors. Look at 9. 1 and 9 makes 9. 3 and 3 makes 9. So I can count the 1 as a factor, the 9 as a factor, and the 3 as a factor of 9. So 9 would be a composite number because, of course, 3 factors is larger than 2 factors. So more than 2 means that the number is composite, more than 2 factors. All right. Here on this slide, I need for you to copy this chart, and I need for you to put this on page 25 in your notebook. Your notes should be on page 24 from this video, and then you can draw this chart on page 25, and you try to see if it's prime or composite, and we'll check this in class. Make sure you list the factors that can make each multiple, the multiple 10, 11, 16, 13, 21, 24, and 19. And don't make the mistake of thinking just because a number is odd that it's prime. All odd numbers are not prime numbers. There are most numbers that are prime are odd numbers. 2 is the only even prime number, but there are odd numbers that are composite numbers because they have more than 2 factors that can make the number, that can make the multiple. So make sure you don't make the mistake of thinking just because a number is odd that it's prime. List the factors in the factor column and then tell whether it's prime, composite, or neither. All right. I'll be looking for this in your notebook on page 24 and 25. Remember the video notes on page 24 and this chart on page 25. You have a good night.